Welcome to September 8th LeetCode Challenge, Binary Tree Inorder Traversal. Given the root of a binary tree, return the in-order traversal of its node's root value. So say we have the binary tree here, 1, null, 2, 3. We want to return the in-order traversal, meaning that basically we go 1, and we see 3, and then we see 2. So in order meaning that everything we see from left to right is from top down is the in-order traversal. So root is empty, return empty node, return empty list, just to say. Root has only one node in it, then return that one node. The number of nodes in the tree ranges between 1 to 100, and each value of the node is -100 to 100. Alright, the recursive solution is trivial. Can you do it iteratively? Oh. Well then, first of all, let's do it recursively. So if root is none, then return the empty list here. So let's see. What do you want? The recursive case would be the in-order traversal. So basically, we would call recursion case on the root.left. We call it on the value itself, and then we call on the root.right. So ideally, we just have to do self.in-order traversal. We call root.left. Concatenate that with the root.value inside a list, of course. The self.in-order traversal of root.right. And this will return the in-order traversal of the binary tree, because we can count it each time. Let's run the code. Submit this. Alright, so that's basically a recursive case for it. It's not very good time complexity or memory complexity because time complexity wise, it's basically big O of n, where n is the recursion, so we have basically big O of n. And space complexity is big O of n as well, because worst case requiring n space. The average is case is actually big O of log n, with the number n, or n is the number of nodes. So that's basically the solution to using recursion. Can you do it iteratively? I don't know, let's see. So say we so that's submitted. Let's try to do this iteratively if we can. So say we develop a couple of the following. Say we have two variables called nodes and the current node, right? And we assign it to be empty list and the root. Say while the current exists, we're going to iterate through and find if not current.left, then we want to append to node, and we want to append the current value val. And then we update the current value to be current.right. And then we continue past this. So that's the left node, and then we are going to look at the previous node as well. So if we look at the current node and we look at the previous node, let's say we call this prev, and we want to basically assign that to current.left. Then while the previous node .right and the previous node .right is not equal to the current node, then we want to update the previous node to be prev.right. However, if it is not the previous node.write, we also want to update or swap previous node.write with the current node, and we also want to update the current node to be the current.left node. And then else, if this is not the case, then if it's not previous.right, then it's previous.left, then we have to update the current.left to be none. And then return nodes. Let's see if this works. Right there. Does it actually work? Well, this is the memory complexity is pretty good. It's big O constant space in terms of memory, but the runtime complexity is not very good because it's big O of n with an n size of node. But it is using it iteratively, and I believe this is using yeah, so that's pretty much it, I believe. Alright, that's it. Have a great day, guys.